Welcome back to Apt4U. In this particular video, I will be discussing about the Towers of Hanoi puzzle. Basically, my main objective will be to unfold or unroll the recursion step. Okay, I will just focus on how the recursion is actually helping to solve the Towers of Hanoi puzzle. There are plenty of videos available on YouTube which have discussed how the what is Towers of Hanoi puzzle and what is the equivalent code for it, but I didn't find any video where they have actually explained how the recursion is actually working, and so I have just tried here to explain that particular aspect of the problem. Okay, so I will just discuss about how recursion is actually helping to solve the Tower of Hanoi puzzle. So I will expect you to know what actually is the problem, what is the Tower of Hanoi puzzle, and I hope you have also understood what the Towers of Hanoi puzzle is before watching this video. Okay, if not, then no problem, I'll just give a brief overview and then I'll just directly jump into the working section of the Towers of Hanoi puzzle code. So if you just look into the Towers of Hanoi puzzle, so as per the problem statement, we have three towers. One tower is called the source tower, another is the destination tower, and we have an intermediary tower that is called the auxiliary tower. Okay, the source tower consists of certain disks, okay, arranged in the ascending order. Ascending order in the sense from top to bottom, it is arranged in the ascending order. The disk at the top has a smaller radius, the disk at the bottom has higher radius. Our objective is to remove or move all these disks from the source tower. All these disks we have to remove from the source tower and place it in the destination tower, right? Quite an easy task, but yes, you have to follow certain rules. What is the rule? Rule 1 says that only one disk may be moved at a time, so you can remove only one disk at a time. And rule 2 says that you can only remove the topmost disk. Okay, at any tower you can only remove the topmost disk. You cannot remove any disk in the bottom or the intermediate positions. So you can only remove one disk at a time from one tower to another, and you can only remove the topmost disk. Third says that no disk may be placed on the top of a smaller disk. Means you cannot have a condition where you placed a bigger disk over a smaller disk. This is an invalid move. So keeping those things in mind, we have to solve this particular problem. So basically, if I give you a short intuition, let us suppose we have only one disk. Okay, suppose we have only one disk, and this is my source tower. Okay, so this is my auxiliary tower and this is my destination tower, and this is my source tower. I have only one disk and I want to move it to destination, right? So I can directly move this from, suppose this disk number is 1, so I can directly pick it up and place it in the destination position directly. My problem is solved. What if I have two disks? So in case if I have two disks, suppose I have two disks. So basically this is my disk 1 and this is my disk 2. As I said, the topmost disk is smaller in size, the bottom disk is larger in size. Now this is disk 1 and this is disk 2. So I have to remove this to destination tower. This is my destination tower, this is auxiliary tower, and this is my source tower, suppose. Okay, ignore this for the time being. So what will I do? I will pick this source, okay, this disk from the source tower, the smaller disk, and place it in the auxiliary tower, right? So disk 1 is placed here. Now I will be left with disk 2, isn't it? I will be left with disk 2. So now disk 2 can be placed in the destination tower first. So I'll pick it up, I'll place it in the destination tower, disk 2. So disk 2 is removed from this position. Source tower is empty now, and the disk 2 is already placed in the position. Now we can just pick this disk 1 and place it top of disk 2. Alright, so now the auxiliary tower becomes empty. So we can see that successfully we have moved all the disk from the source tower and placed it into the destination tower, and meanwhile we have also used or taken the help of this auxiliary tower, isn't it? We just saw. So this is my objective. How can we solve this using a code? Can we have a proper algorithm? Yes, definitely. This we just solved it manually, but if you follow it carefully, the steps that we did was we moved the top n-1 disk. That is, when I had 2 here and 1 here, the top n minus 1, here n is equal to 2 because we have 2 disks. So the top 2 minus 1 means 1. The first disk, the top disk, what did I do? I picked it up and moved from source to auxiliary. So I basically had placed it here, isn't it? The one disk number 1, I had placed it here. Then the nth disk, the last disk, I had picked it up and moved to the destination from source. Then I had moved the destination the second disk and placed it into the destination tower. And then finally I picked up the disk, the n-1 disks from auxiliary tower, and I had placed it into the destination tower, right? Can we code this? Yes, of course we can code this. So just for the time being, keep in mind these two steps, very important. The first step, moving the n-1 disk from source to auxiliary tower. The second is to move the nth disk from source to destination, and the third, moving the n-1 disk from auxiliary to destination. These three will be implemented in the code, right? Let us quickly jump into the code section and then we will unfold the recursion part. So here is the code for this problem. So let me just increase the font size. Or it's fine. Let's continue. So here I have defined the function move. Okay, the move, I have defined the function. It is a void type function. The parameters that I am receiving, please pay attention to the parameters that is being received. N is the number of disk. This from, that is the first argument here. Okay, just remember at the first position we have the source. Okay, whatever you pass at this position will be considered the source. The 2 here, whatever you passing at here at this position, that is the destination, and whatever you pass here is the considered as the auxiliary tower. Okay, so if you have 3 towers name, the first tower name will be considered the source, the second tower name will be considered 2, that is the destination, and the third tower name will be considered the auxiliary tower. So the base condition, this is the base condition. This basically is the base condition. Base condition says that if n is equal to 1, if there are only one disk, then just move that disk from the source position to the destination position. You can see, move the disk from to rod 2, and this is basically nothing but the source, and this 2, as I said you, is nothing but the destination, right? So if n is equal to 1, we will just move the disk from source to destination. Fine. And what is the main task that we have to do? If n is not equal to 1, as I said here, that we will first of all move the top n-1 disk from source to destination, right? As I said you, the first argument is the source, the second is the destination, right? As I said here, that we are passing, let me erase it. Fine. As I said you, within the function move, the very first value is the number of disks, the second value says the source tower, and the third value says the destination tower, and the fourth argument gives the name of the auxiliary tower. So here what we are passing, the number of disks, and we know that the first tower name here will basically be the source tower, so this is the source tower only. And now the auxiliary tower is being considered as the destination tower here. Okay, and we know that the second will be destination, so we are considering the auxiliary tower to be the destination tower, and this is 2. And we know that the fourth argument is basically the auxiliary tower, so the 2 was our destination tower, isn't it? So this 2, which was the destination tower earlier, will now be considered as the auxiliary tower. Getting the point? So I hope you have understood what is actually happening here. Means here we are doing a recursive call. This is a recursive call. You can clearly see, calling a function move with inside the function move. So it is basically a recursive call. Again we are printing some statement, right? And again we are doing a recursive call on the function move, that, and we are passing n-1 disk. This time auxiliary tower is my source tower. This will be considered as a source. The destination tower is the destination tower only, and the from tower, that is the earlier the from was source, right? But now in this time this will be considered as auxiliary tower. Getting the point? So this is how the code is actually working. Now I'll be directing you towards the main objective of this video. How is recursion helping to solve this specific problem? So basically I have considered the program and I'm already ready with the recursive tree. So how is it working? See, suppose this is where the program execution will start. Okay, inside main we had, you can see inside main I am receiving the value n as input. Suppose I will be entering n equal to 3 and I will call the function move from here itself. Okay, here is where the function will be called for the first time. So this particular line I have copied and placed it at this particular position. Okay, so here it is. This is where I will call the function move, and remember I have taken n is equal to 3. Fine. This print statement I am indicating it by a label p1. Okay, whenever I write p1, you just understand I am trying to print this line. Whenever I will write p2, you understand that I am trying to print this particular line. So now we are basically doing the call move, and the value we are passing is 3 because I will be taking 3 disks. Okay, and the source tower will be A, the destination tower will be C, and the auxiliary tower will be B. Okay, fine, I hope you got it. So I am starting my execution from this point. Okay, the function is called control moves to this point. So basically I will be writing here from to auxiliary. Getting the point? Because when I passed A, C, B, A will be considered as the from, that is the source tower, C will be considered to, that is the destination tower, and B will be considered the auxiliary tower, and that is why I have written F, T, A here. So A is considered to be the from, that is source, C is considered to be the to, that is the destination tower, and B is the auxiliary tower. Fine. We will get inside. This condition we are checking if n is equal to 1 or not. So we will first of all start from here. The first statement that we executed under this is if n is equal to 1 or not. So if n equals 1 or not, the result will be false. Why? Because n here is 3, right? So the output is false. So basically we will not enter the loop, right? We will not enter this if loop. What will we do? The control moves towards this statement move. So let me write move n minus 1. What is the value of n here? Right? So we executed this particular line, this particular code function, and inside that we are executing its line. The first line it executed under this is this one. Second line that it will execute is this line, right? Move n minus 1, that is 2, comma from auxiliary to. So the value of from is A, right? So A will be passed here. Second argument it will take auxiliary. What is the auxiliary value here? B, right? So it will take B. Third is 2. What is under 2 here? C. Getting the point? So now the A becomes the F. Okay. B becomes T. C becomes A, which means earlier F was source, here also F is source tower only. Earlier C was the to tower or the destination tower, but here C becomes the auxiliary tower. Earlier B was the auxiliary tower, but now B becomes the target tower, okay, or the destination tower, which means the auxiliary tower here becomes the destination tower at this point. What will we do next? Now you see, first of all this function was called here, so I just started executing this function. Once I am started executing this function, I will get inside the loop. I will execute the first statement under this. This was false. Then I will execute the second statement under this, which means this one. Now this again is a recursive call. Now since this is a recursive call, so again I will start executing the function from top, isn't it? Because this is a separate call. So what will I do? The first line under the move function, is if n equal to 1 or not. So if n equal to 1, what is the output? The output is false, right? Because n is 2 here, right? So n equal to 1 is false. Second, move. So basically I'll write here move n minus 1. N minus 1 is nothing but 2 minus 1 is 1. So let me just write with black ink. Okay, getting the point? So I made a recursive call. Since I'm making a recursive call here, so I will start executing from the first line inside the function. This will return false because n is 2, but here I'm saying if n equal to 1, that's over. Now this will become move, let me write m, n minus 1. N minus 1 will give you 1, comma, from. The first argument will be from. So from I have a here, so it will be a only. Auxiliary. So under auxiliary you have c, so I'll write c here. 2. Under 2 you have b, so you write b here. Getting the point? So these are my arguments. So now basically a becomes the source, c becomes the target, and b becomes the auxiliary tower. Getting the point? This is how it is working. Now I will be executing this c out, right? Is it? No. Why? Because since I made a recursive call here, first of all I made a call here, function call here, then again move was executed here, so I just expanded it. Now again you will see move is being called here, so again you will expand this its wing, isn't it? So when I expand the wings of this particular move function, so what will happen? Here you see n is equal to 1. So as soon as n is equal to 1, it will see out this line, means it will see out p1. It will see out p1, right? p1. And what will it print under p1? It will print, we will trace this tree at the end. Okay, so no problem. Just keep in mind we are writing here p1 because when m is equal to 1 and when I expanded this function, it satisfied the base condition, n is equal to 1, so print p1. So I'll print p1 here, that's all. Now control comes back. So first line and second line under this function is executed. What is the third line? The third line says c out, so basically the p2 statement. So this will basically print the p2 statement, right? Because you see, you just focus on this move function. Whenever this move function was called, it had 4 tasks to perform. First task it performed here, second task it performed this call, third task is to print, and fourth task is again to call the function. So fourth task again I'm going to call the function move. I'm writing it as m, n minus 1. What is n? N is 2. 2 minus 1 is 1. Auxiliary to from. So first argument will be auxiliary. So auxiliary was here c, isn't it? Under a you have c, so you will take c here. 2. Under 2 you have b, so you will take b here. Under from you have a, so you will take a here. Alright, so I hope you got the point. So this is the call again you have to make here. So since there is a recursive call here, the function is being called again. So again what will we do? We will perform the execution. So once we execute this function, what will happen? N is equal to 1 here, right? So it will meet the base condition, and once it meets the base condition, p1 will be executed. So again we will print p1 at this stage. Okay. So basically you see we performed all the tasks of this function move. We performed all the tasks of this function move. We performed all the tasks of this move function. So basically we are going to return. Now we came back here. Now if you consider this move function, we have so far performed only the first task and the second task of this move function. What is the third task of this move function? The third task of this move function is, first of all you check n equal to 1 or not, first task. Second was the move recursive call. Third was again p2. So we have to do a p2 call here, right? You will call p2 here. And what is the fourth task of this move function? The fourth task of this move function is, again you have to call the function move, and you have to pass the argument n minus 1. So what is n? N is 3. 3 minus 1 is 2. Because you have to look into the parent node of this. Okay, what is the parent node of this? Parent node is this, and value of n you just received was 3. So 3 minus 1 is 2, comma, auxiliary to from. So basically the first argument here will be auxiliary. So auxiliary, what is under auxiliary? B. 2. What is under 2? C. What is under for? What is under from? Under from you have a. I don't hear it like this. Okay, what the point? So you see, again you are making a recursive call on the function move. Again we are making a recursive call on the function move. So again it's our duty to expand this. So we know that every move function will perform 4 tasks: checking, first call, printing, second call. Checking, first call, printing, second call. Similarly you see, this move also had performed the 4 tasks: checking, first call, printing, second call. Similarly this move function will first do a checking. What will be the checking? If n equal to 1 or not. If n equals 1 or not. What will be the output? The output will be false. Why? Because n is equal to 2 here. Second task under the move function is the first recursive call, that is move n minus 1. So it will, let me write m here for move n minus 1. So 2 minus 1 is 1 from auxiliary 2. So the first argument it will take the from. So what is the from? Okay, let me write here. We know that this is f, this is t, this is a, right? So the first argument from here it will take is from, so b. Then it will take auxiliary value. So auxiliary was a. Then it will take the destination value, the t value, that is c. So it is basically b, a, c. Fine. So you see that again we are making a call here. So once we make a call here, again we are going to expand this, and when we expand this time n is equal to 1, and we know that if the base condition is met, we will print p1. So p1. So under this recursive call, what we did, we completed the first task, we completed the second task. What is the third task? The third task is to print the p2 statement. So we are going to print p2 here. And what is the fourth task left? The fourth task left is the recursive call again. So move n minus 1. So what is the parent node? 2. 2 minus 1 is 1, comma. What we have to find? Aux to from. Means what is the first argument? Aux. And what is the aux variable? Under aux you have a. Take a. 2. What is under 2? Under 2 you have c. So take c. Under from you have b, right? So b. So 1 a c b. Again we are making a call on move, right? Because we are passing, this is the call on move, okay? We are calling the function move wherein we are passing this argument, where we are saying that okay, there are only one disk left. Currently this a is the source, c is my destination, and b is my auxiliary tower. And we know that whenever n is equal to 1, the base condition is met and it will execute the p1 statement. So p1 will get executed at this instant of time. So once p1 get executed at this instant of time, which means I have completed all the tasks of these move functions. I have also completed all the tasks of these move functions, and when I control comes back here, it checks, it sees that, it will find that okay, all the 4 tasks under the move function was done, and hence we return. Now what is the output? How we are getting the output? If you carefully observe this particular code, if I run this code, alright, it is in execution, fine. Let us suppose the number of disks is 3. So please notice that these are the movements that has been suggested by the algorithm in order to move from the source configuration to the target configuration. Let me just take the screenshot, or let us just keep it as at side and focus on the point here. Okay. So now we have already explored the tree. Now it's time to do the traversal. As I said we will traverse at the end. So now it's time to do the traversal. So how to do the traversal? You see, we will start from this point. Let me take the blue ink. Okay. Okay, let us take this blue ink. Fine. So we started from this point. We came at this point, right? I came here. Again there was a call. I came here. I again executed this line, that is the condition checking here. Again we came to this move function. When we came to this move function, what will we do? We will write the p1 statement. We will execute p1. And when we execute p1, what does p1 say? P1 says move disk 1. So let me write the output. Move disk 1. So move 1 from 2. Okay, so what is the from? From here is a, and what is 2? 2 here is c, isn't it? Means from f to print f, print t. That is only there. That is what they are doing here. Okay, they are printing f, they are printing t. So a here I had a, f I had here a, and what is t? The value of t is c. So move 1 from a to c. This is what they are trying to say. I executed this. I came back. Again I had to execute the third statement, p2. What does p2 say? p2 says move disk n. What is the value of n here? If you focus, and if you are at this point, what is the value of n? You know. So basically the parent has the value 2, right? So it basically is saying that move 2. So I am here at this point, okay, p2, and you have to print from n to. So if I am at this point, what is the value of f and what is the value of t? So for that you look into the parent node. The value of f is a, the value of t is b. So move 2 from a to b. Getting the point? So I executed the third statement of this move. Again I will execute the fourth statement. What does the fourth statement says? There is a call on the move function, and when there was a call I had to print p1. What will I print? P1. So what does p1 prints? P1 basically prints move disk 1. So move 1 from to 2 means what is the value under f, what is the value under t, you have to check. So if I am at this position, I'll look into the parent node. What is the value under f? So fta. The value under f is c, the value under t is b. Right? So the value under f is c, the value under t is b. So move 1 from c to b. This is what they are trying to say. So we successfully executed all the 4 statements of this move function. So this task is complete. Control comes back here. Now if you consider this move function, I have so far executed only the first task and second task. The third task of this move function is to execute the p2. And if I am standing at this position, I will look into the parent node. What is the parent node? This node. This is the parent node. And what does p2 prints? P2 prints the value n. So basically what will I print? Move. What is the value of n? If I am standing here, what is the value of n? The value of n, I'll just look into the parent node. 3. So move 3 and print the value of from, print the value under 2. What is the value under from? A. What is the value under 2? C. So move 3 from A to C. Getting the point? So basically we have successfully completed task 3 of this move function. Now I am at this point. Now I will be executing the fourth task, and when I execute the fourth task, I'll come at this point. Again I found that okay, there is again a recursive call on the function move. So I will just expand its branches. The first branch says this condition, it was already done, executed. When I came to the second task of this move function, there was again a recursive call on the function move, and I had to print p1. So when I had to print p1, so I have received the value ft here. Okay, we know that what will p1 print? P1 will print move 1, because we know move disk 1 from and to. What is the value of from? The value of from here is b and 2 is a, right? Under from we have b, under 2 we have a. So move 1 from b to a. Okay, so this task is also completed. So we have completed the first task and second task of this move function. We are now left with the third task. What is the third task? The third task is p2. What is p2? p2 says move disk. So move disk n. What is n? If you are standing at this point, we will look into the parent node. The parent node has the value of n as 2. So move disk 2 from what? From to 2. Okay, so you write from first, 2 second. So if you are standing at this point, what is the value under from? The value under from is b, the value under 2 is c. So move 2 from b to c. Get the point? So this task is also completed. So we have successfully completed the first task, second task and third task of this move function. The fourth task of this move function was again a recursive call on the function move. Okay, we did a recursive call, and we already know that the first argument is always f, the second is t, the third is a, whatever we have assumed. Okay, and when we executed this, we got p1. And what did p1 say? P1 said us to print move 1. Okay, and print from and print 2, means print the variable under from and under 2. So under from we have a, under 2 we have c. Fine. So we've successfully completed all the 4 tasks of this move function also. And if we come back, we have also successfully completed all the 4 tasks of this move function also, and hence the recursion stops. And you will find that there are 7 steps present here. Okay, we will try to match this with the output that we have received here. So if you see, if you compare, you will find that okay, move disk 1 from a to c. So see, this is matching. Move disk 2 from a to b. Move disk 1 from c to b. Move disk 3 from a to c. Move disk 1 from b to a. And move disk 2 from b to c. and move disk 1 from A to C. Fine. So total 7 steps. Number of disk was 3. Shortcut formula to find how many steps will it take? 2 power n minus 1. This is the time complexity of this particular Tower of Hanoi problem. Okay, order of 2 power n minus 1. But if you want to find the number of steps, it will be simply 2 power n minus 1, 2 power 3 minus 1, which is equal to 7. Okay. So the video was quite lengthy, and I hope this will be really very helpful for you. Please give your feedback and help me improve. That's all. Thank you for watching. Please like and subscribe for more interesting videos.